Hello and welcome back. I'm Joe Strout, and this is a live coding session where we are creating the base defender game in MiniMicro. So let's start by reviewing what we've got so far. Main program is called main. And wow, that's disappointing. I swear this worked when I left it. I haven't touched it since last week. But I guess we get to do some debugging. Sometimes errors like this happen because something was defined in an earlier run of the program and I didn't reset, but my usual habit is to reset and then run. So I don't know why it would have worked before and it didn't work now, but let's just get to the bottom of it. Let's edit enemies and look at line 13. Enemy.addBox. Let's see. That would come from, well, that's a good question. Where is the addbox program? It's probably in function, It's probably in main. Nope. Let's see, constants, enemies. I wonder if that function just got lost. Let's look at some other files though. Player.addBox. Oops. No, oh, it's addBbox. Okay. Well, that might be why I didn't find it before. So let's check main again. Yeah. So this function gets added to the sprite class in main right now. But we're importing all these other modules before we do that, so that's not going to work. I think what I want to do is move all these sprite extensions into their own module. That'll be a little bit neater anyway. So let's take all of these, cut them, reset, edit, paste, get rid of the find dialog, and then we're going to save this as sprite extensions. And then, let's see, does this need anything non-standard? I don't think so. Color lerp is standard on MiniMicro. So yeah, this is probably okay. So now what we can do is in each of the modules that needs that thing, like enemies and player, we'll ensure import sprite extensions. Let's save that, edit enemies, do it here as well. All right, reset, run main. Hey, look at that, okay. Well, that was a bit of excitement, wasn't it? Okay, so, oh boy, there's a lot of these guys. They're ganging up on me. Good thing I have infinite hit points. Okay, so that's pretty cool. I did have a thought over the course of the week. I was thinking, instead of just having the sprites when they hit something come to a stop, which since they then immediately move forward, it really looks like they're just slowing down. I want to have them actually bounce off by backing up when they hit something a little bit. So we're going to do that, and then we'll look at our progress log and see what might be next. But let's start by editing enemies. And let's see, pick a target, hit something. If the other's an enemy, we do nothing. Handle collisions, check collisions, self.hit SP. Okay, right, this sets the speed to 0. But in addition to setting the speed to 0, I think I want to back up a little bit. We can do that by calling self.move forward with a negative distance. Let's say like 3 pixels. Let's see what that looks like. Reset, run main. Yeah, now I can actually push them back, which is kind of neat. And when they hit the castle, they don't go inside it, they stop. Yeah, I like that better. That looks really cool. Get off my castle. All right. So, what's the next step? One thing I did since our last session is I started a progress log. This is something that I typically do on any project that's going to take more than an afternoon to finish. And especially if I think I'm not going to get to focus on it consistently for a number of days in a row, I make a log and I write down what I'm working on and what my thoughts are about next steps and that sort of thing, so that when I pick it up, I can pick up right where I left off. And this is my entry from last week. This is all checked into GitHub, so you can go read it there if you want to. But basically my plan for the next session, which is today, was to add towers, which shoot at the nearest enemy, and that means we'll need to have projectiles. And then if I get time, I might add a tile display, which maps out obstacles so that the enemies can't just go straight for the castle. They'll have to work their way around some barriers, and that'll provide more strategic opportunities, especially for where you place your towers, once that's the thing. For now, the castle has 4 towers, and we could also just hard code a tower out here somewhere, and the towers should shoot at the enemies. And for that, we're going to need projectiles. So I think it makes sense to do projectiles first, and I can just hard code a projectile spawning out of nowhere for the sake of testing. I did do a little bit of graphics work since last time. So let me show you what that looks like. For projectiles, I created this graphic here in my drawing program. And my thinking is I want projectiles to grow sort of a tail as they shoot across the screen. So it'll start off just a block, but then it'll be a block with a little tail and then a slightly bigger tail and so on. So we'll take this image and we'll divide it up into 8 rows, each with a longer tail. And then we'll use those to make it look like the projectile's stretching that tail out as it flies. If I do, view, find file, you can see what that looks like on disk. Here's my projectiles sprite. So that's pretty big. I'll need to scale it down just like I did with the unit sprites, but that's okay. And we're going to need to carve that up. And that sounds like a job for the resources module. So let's edit resources. Okay. We'll call it, let's see, we have the player unit sprite sheet and sprite image, player sprite sheet. Building sprite sheet, and the castle image comes out of that. Now we'll have projectile sprite sheet, file.load image, pics, projectile sprites.png. I think that's what it was. Oh, it's just projectiles. Okay. I thought I could go back to the word break, but that's a different editor I'm thinking of. Okay. And then, let's see. Let's just carve it up right now. Projectile images. It's going to be an array for I in range 0 to 7. Projectile images dot push. Projectile sprite sheet dot get image. Open paren, and let's see, the x will be 0. The y will be 64 minus, if I make this 1 to 8, then we can say 64 minus I times 8. And the width will be, should be projectile sprites. The width will be 128. Might not have been obvious, but there's a bunch of blank space to the right of each projectile so that the center is right at the head of the projectile. Because the center of a sprite, the point about that it rotates around is always at the center of the image in Mini Micro. And then the height will be 8. So that should get us our projectile images. So let's run that. Line 18 Doesn't like projectile sprite sheet. Oh, yeah. Okay, let's try that again. Now let's view projectile images. 0 should be just a square. And then if we go like 3, it's got a bit of a tail. If we go 5, more of a tail, and the last one would be 7, longest tail. Cool. And of course, it's white so that we can tint it the color of the player enemy as needed. Alright, so we have our projectile images. Now we need a projectile class, and I guess that might as well go in its own file. So let's say projectile.ms, and what do we got? Let's see, projectile equals new sprite, projectile.update equals function. Let's see, we basically just want to do move forward by a certain amount. We'll have a speed. Okay, and then we also want the tail to stretch out, so let's see. Let image index equals 0. Self.image index plus equals 0.2. So this would make the tail stretch every 5 frames. That might look good. If, let's do it this way. If self.image index is less than 7, so it goes 0 to 7, then add 0.2 and self.image equals resources dot projectile images self.image index. So you might notice I'm indexing into this list with a floating point number that may have, a fractional part, but that's okay. When you do that, it just ignores the fractional part, uses the integer part to index into it. And so that'll give us an image 0 through 7. Yeah, this is just about enough to start testing it. Where I need some imports, especially if we want to test it on its own, which is always a good idea. So import util, and then ensure import resources. Okay, let's try this much. Yep, that works. Now if locals is equal to globals, then that means this is being run as the main program, and we want to do a little test. Make a new projectile, call it P, start it in the center of the screen, and then while true, so we can just hit Control-C to break out. P.update yield. Let's see what that looks like. Looks like nothing because we didn't actually add it to the sprite display. Display for sprites dot push P. Zoom. Hey, that was pretty cool. All right, the other thing I want to do is shrink it down. So scale 0.5 and projectile dot tint equals, how are we doing the tints? Constants? Yeah, constants dot player color is what I want. Constants dot player color. Okay. Save it, run it, zoom, cool. It looks pretty good. Yeah, I think I like it. The tail is pretty subtle, and I don't know if it's coming through on YouTube at all, but it looks pretty good from where I sit. So we have a projectile. Projectiles shouldn't just keep flying forever, though. They should have a limited lifetime. Which I'm going to measure in frames or update calls. Life. Let's see. We'll call it frames left. And we'll have that start out at, let's see, it's 60 frames per second. These projectiles shouldn't last more than a couple of seconds, so we'll say 120. If how about self.frames left minus equals 1, if self.frames left is less than equals 0, then we're going to do I have a name for the sprite display? Sprite disp. Yeah. Yeah. So we'll call it sprite disp. Edit projectile. Okay. Sprite disp.sprites.remove val self. So we want to ensure import list util, because that's where remove val is defined. And then we also want to make sure that sprite disp is defined even when we're running locally. So let's call that display 4. And then we should use that here instead of these. Save it, run it. Let's see. And we'll loop as long as the sprites contains P. Yeah, so it should only go 120 frames and then it should stop. Okay, I think it's doing that, but 120 frames is enough to go clear across the half of the screen there, which makes sense. It's going 10 pixels per frame for 120 frames, so that's 1200 pixels. Yowza. We either need to shorten the lifetime or make it move more slowly. Let's do a little of both. Let's move 8 frames, 8 pixels per frame, and let's see. 100 frames would be 800 pixels. That's still too far. 50 seems pretty good. You know what? I feel like maybe it's still going too fast. So this would be 5 times 50 or 250 frames. Nice. Yeah, that looks pretty good. Now with that speed though, will it actually be able to hit enemies that are running away? I don't remember how fast enemies are. Their speed is 4. Ugh. Okay, if their speed is 4, our projectile I think needs to go at least twice that speed. I'm trying to find a projectile in my history buffer. Okay, so we're gonna go 8. And let's see. 40 frames, that'd be 240 pixels. That sounds pretty good. Yeah. Okay. All right, so we have a projectile. Now, towers. I guess that's the next thing. A tower consists of a stationary base and a rotating turret, and it fires projectiles. All that sounds like it needs its own file, huh? Reset. And let's look at our resources. We have the building sprite sheet out of which we've plucked the castle image, but nothing else. So we need to get some more images out of here. So let's look at why is this? What? You don't know the word resources? Because I did a reset right up here. Fine. All right, run resources. Oh, come on. Right. I didn't want to run it. I really wanted to import it. But actually, this is fine. We can just do this. And if I view that, it looks like this. Okay. So here's a tower. A standalone tower. The castle also has smaller towers. But I think I want to do the standalone tower first. And then here's the turret that goes with that tower. It's going to rotate. Easiest way to get those coordinates, I think, will actually be to look at the original file over here. So let's see. I had worked out how to do this. Darn it. Nope, I gotta stretch this window out as I can't remember how I got to the layers. Buildings, unit sprites off. Okay. And we're zoomed in more than we need. Okay. So these major squares here are 64. So 64 by 1, 2, 3, 4. Well, it starts at 3. 0, 1, 2, 3. Yep. And this tower looks like it's 48 by 48, actually. So starting at 64 by 3 and starting 1, 2 and a half 64s up. Let's see if I can find that in the sheet. So view building sprite sheet, get image, 64 times 3, 64 times 2.5, and it's 48 by 48. Well, nope, I missed. Maybe I just got the size wrong. Yeah, that's a quarter of the tower. They're actually 96 by 96. Okay, that's that. And if I want the rotating turret part, I think that would start at 2.5 minus 1.5, which is just 1, 64 times 1. There's the rotating turret part. Cool. All right, let's start with this. Oops. Copy that, edit. All right, turret image equals that. Oh, actually that's the tower image. Turret image equals, this was at 64. And then let's run it and just double check. View tower image. Yep. And view turret image. Okay. So we have those. Let's reset. And make a tower class, which is actually, you know what? To get started, I could copy some of the setup code from the projectiles. So let's load projectile, save it as tower, and now edit. So this stuff up at the top is all good, but tower. All right, how do we want to organize this? Because this is the first game object we have that consists of two sprites, stationary base and rotating tower. And I think we actually want to do I'm sorry, I know I need to think out loud because that's the point of the video. I'm thinking if I don't want the main program to have to worry about both objects. I want it to just refer to one and then that object has a reference to the other. But the question is which one? If we refer to the turret, then we can easily interrogate its rotation if we care. but I don't know that we should care. And for that matter, if we did care, and we referred to the base, the tower itself, we could just make a rotation method on there that calls through to the rotation of the turret. I think I like that better, especially since I called the file tower.ms. So yeah, so let's refer to the tower, and then the tower will create a turret. So tower.image equals resources.towerImage. And like all the others, at this point, we're going to scale it 0.5. And then, let's see, tower.makeTurret. Well, actually, we'll make an init method. And we'll call this on new towers after we create them. And one of the things it's going to do is create a turret. Which I think deserves its own class. So tower is going to be what the outside code looks at, but inside this module, we'll have a turret. Resources.turretImage. Turret.scale equals 0.5. Turret.update this function. For now, we'll just do something like self.rotation. This equals 5. So that we can see that it's working. Okay. All right, we're going to have the init function go ahead and add it, the tower and the turret, to the sprite display. So sprite_disp.sprites.push self, sprite_disp.sprites.push self.turret. Oh yeah, and let's have this take x and y. Self.x equals x. Self.y is y. This is x. Self.turret.y is y. Okay. So let's have our test code. If locals is equal to globals, then sprite disp equals display4, sprite disp.clear, sprite, let's see. T equals new tower init. Oh yeah, init method should always return self, so that you can do stuff like this. Init. We'll just put it right in the middle. 48320. And then while true, I could have kept this from the other program, huh? And it wouldn't be quite the same. T.update, T.tower.update, yield. So I said, I'm sorry, T.turret. So in the main program, it won't work this way. The main program just iterates over all sprites, and it calls update on all of them. So the tower method actually needs to have at least an update entry in its map, but it doesn't have to do anything. You can just say null. And that should work. Save it, run it. Hey, there we go. You can see there's a tower with a turret and the turret spinning. So that's looking pretty good. Now let's make it fire periodically. And one thing I'm pondering is whether projectiles are going to just be fired in a direction, or whether they're going to actually be given a target to seek out. And that's something we're going to have to deal with in a minute. But for now, we'll just fire them in a direction. So, tower.fire function. Oh, and so maybe we will use the update method, because I think the tower is where the logic's going to live, and the turret is just... No, that's not true. Because on the castle, it doesn't need the base, actually. It just needs the turrets. It needs 4 turrets, because the castle sprite already has places for towers on there. So maybe the turret is where most of the business logic should live. So we're going to keep the update null on the tower, but on the turret we're going to have a fire function. And it needs to know about projectiles. Turret.fire equals function. Nope, that was my watch wanting to tell me something. Sorry about that. Okay. Turret fire equals function. So we're going to say p equals new projectile. P dot x equals self dot x. P dot y equals self dot y. P dot move forward. We want to start at the position of the end of the turret, ideally. So how big is that? I don't think you can see here. If I move this over, you can see it. I can measure this. Oh, actually, it's measured right here in the window as well. But it's tiny. So this is a width of 40. This is a width of 48. So we'll have it move forward 48 times the scale, of course. So move forward 48 pixels times self.scale. And let's see, we have to set the direction by the rotation. Self.rotation. And we really should do that before we tell it to move forward so that it moves in the right direction. Okay, that's cool. So how are we going to test it? Well, for now, we'll just say in order for this to work, I need to do just like the main loop does and say for sp in sprite disp.sprites sp.update instead of doing the separate ones. And we'll say if RND is less than 0.05, 5% chance, then t.turret.fire. All right, move forward, not found in map. That's a good point. We need those sprite extensions. Still not found in map. What you talking about? Use sprite extensions. Oh, that mess. Sprite, move forward, right there, big as day. It's supposed to be a capital projectile. I'm not sure what that was doing. Oh, projectile was the name of the module. So it was just subclassing the module itself. That's a silly thing to do. All right. And we need to add it to the sprite display, don't we? So we'll do sprite disp.sprites.add p by adding push p. Okay. Projectile unknown. Yeah. Okay. This is a fair point. In this project, I'm choosing to have most of my classes, certainly the ones that I'm likely to need to reference, have those in the global namespace. So I'm going to do that to turret and tower right now, and then I'm going to edit projectile. I need .ms with edit, and we're going to do it here too. Globals.projectile. Yeah. All right, let's reset and run tower. Hey, nice. That's that clear. Cool. Look at that tower shooting. That's very exciting. All right. I think we should put one of these in the main program as our next step. So let's edit main. And where's our setup? We'll just do it here for now. So we'll say, we'll make sure that we've imported it. Power. Okay, and then we'll say new tower dot init, and we'll put it a little bit left of center. So let's say 300, 320. Oh, that doesn't look so good. Suddenly my frame rate has gotten awful. What is that? Nothing I'm doing. That's terrible. Okay. Let's check the length of our sprites. Sprite sprites.len 19. That's reasonable. Because I see 6 of these guys, 8 of these guys, that's 14, 15, 16, 17, 18. Yeah, I probably miscounted somewhere. 19 is reasonable. I thought maybe I had, was adding a new tower every frame and they were just piling up, but that does not appear to be the case. So what could make it so slow, especially when I test the tower by itself and it's perfectly fine? Yeah, that looks good. This is a puzzler. Edit name. I didn't import projectile, but that shouldn't matter. The whole point of ensure import is that it doesn't matter from where you import something. It always has the same result. We're clearly adding just one new tower here. Update flash, enemies update. Wow. Okay, let's just comment this out and verify. Super speedy. Put this back, and I'm going to get a reference to it. Yep. Right, and if I'm doing that, I need to put parentheses around it because I'm calling it like a function. And yeah, it looks terrible. T is a tower. It's got a turret. Why is it suddenly tanking my frame rate? Oops. All right, it's got to be the update method. But this update method is trivial. This update method is null. That's not a problem, is it? Shouldn't be. It wasn't here when we were updating all sprites in our little test program. Well, let's try making this null as well. Still no good. Terrible frame rate. It's just not updating now. No errors are being printed. But somehow having that in there is causing grief. Now, it's got to be because it's on the sprite list. Let's look at what enemies are doing. Because there is a point where they look at all other sprites, I think. Check collisions, yeah. Iterates over all sprites. If it's not equal to self and it overlaps and it's facing, oh. How does overlaps work with a sprite that doesn't have a bounding box? Because I did not add a bounding box to those things. Could that be doing some really slow operation? Let's say equals enemies 0. Enemies to enemy 0. E dot overlaps T. That returns null. Turret also null. Which evaluates to false. So this shouldn't be a problem. That should just get false right here and short circuit the rest of it. I'll tell you what. Let's find out if that's a problem by commenting out the check collisions call initially and reset run main. Yeah. Oh. You know what? It gets slow as soon as I move the player, and that's because that's when the player starts checking for collisions. So somehow my attempts to check for collisions on those things are really slow. On the tower specifically. Because it doesn't have a bounding box, I guess. That's really interesting. All right, let's go to player. Check collisions. Let's say sp.local bounds is not null, and it overlaps and it's facing. Okay, now I can zoom around and it doesn't slow down at all. Let's do the same thing for enemies. We'll put the check collisions call back in there. We'll say if sp is not equal to self and sp.local bounds is not equal to null, and it overlaps and it's facing, then hit it. Reset run main. Okay, cool. Nice. All right, let's get that turret spinning again. Okay, so it should be updating. Reset run main. Okay, cool. Man, our hour's almost up and we don't have these things actually shooting at the tower, at the enemies yet. So let's do that. Okay. I think we want to pick a target, but we don't want to do it every frame, because it's going to be a lot of distance calculations. I feel like that's going to get expensive. Here's what we'll do. We'll have the turret consider one sprite per frame. And if it's closer than the current target, or it doesn't have a current target, it'll set that as its new target. Okay, let's do that. This is gonna work. Turret.target is null. Turret.next check index equals 0. Okay. If we'll do self.next check index is 1 if self.next check index is greater than or equal to sprite disk sprites.length, then go back to 0. Okay. Now sp equals sprite disk.sprites at that index. if SP is a enemy, then we can consider it. Dist equals math util by distance from self to SP. All right. If we'll keep the target distance too. So if self.target is null, or distance is less than self.target dist, then new target self.target equals SP. Now, we want to rotate ourselves to point at the target. I can't remember if I put something in sprite extensions for that. Let's see, we have is facing. We don't have face. To do that, we can just use atan. Self.rotation equals, in fact, this very same atan that we use to check if we are facing. So sprite.face target. Cool. Add tower. So if not self.target, then return. Otherwise, self.face, self.target. And self.target dist equals max_distance self_sp self.target. So we have the distance, we're facing it, and then we'll be able to use that information to fire a projectile every now and then. But for now, let's just see if it tends to face the closest target. I think that should do it. Just put in a little white space. All right, reset that main. Let's kite some of these guys over. Yeah, look at that target facing that. All right, let's get some else. Yep, pretty good. Sometimes takes a while to notice a new target, but then it does. Cool. All right. So now we gotta make it shoot. And we need, oops, tower. So we can't just have it fire every frame. That'd be too much. We need a cooldown frames. And we'll set this in the base class, and then we'll update it in the instances. 3 times per second seems like a reasonable rate. Does it seem like a reasonable rate? It'll do for now. So self.cooldown frames equals minus equals 1. So if self.cooldown frames is less than 0, then self.fire. Okay, fire is going to start a projectile, and it's also going to do self.cooldown frames equals super.cooldown frames. That'll reset that. Yeah, that might work. Reset run main. Okay. Cooldown frames not found. Line 43. I probably did something silly. What did I do? Cooldown frames. Turret. I don't get it. Cooldown frames. Yeah, no, that's what was there. Super here should be the base class. It should be this thing. I mean, we can try being explicit about it. No harm in that. Huh. I have to think about that. Okay. The trouble is, these little buggers are so fast, it's never going to hit them. We would have to lead or track or something. Which isn't a bad idea. This is a high-tech sort of theme we've got going here. These aren't arrows, they're high-tech projectiles, so maybe they do track their targets. Oh, the other thing though is we don't want to shoot when they're too far away. So, if, oops, at a tower, if we have cooldown and self.target dist is less than, let's say, 200, then self.fire, and if. Okay, so I've already gone, I think, for about an hour, but before I wrap up, let's get the projectiles tracking the target. And we're going to do that by doing p.target equals self.target and hopping over to the projectile method, or projectile module. And if self.target, then we should initialize that. Base class self.face self.target. Yeah, this is a good job for a one-liner. Okay, let's see how that looks. Reset run main. Oh yeah, that looks nice. Only problem is that it's not having any effect. Interesting. Okay. I want to know when an enemy is dead. I think that's going to be handy. So enemy hit points is 10. Oh, enemy dot dead equals function. Return self dot hit points equals to 0 and function. That's a good default function. Although actually, when we die, I think I'll just store that on the thing. Self dot dead equals true. And if I'm going to do that, I might as well just have this be false. Be faster. Okay. So we'll know when our target is dead, and let's have both the tower and the projectiles react to that by clearing their target. So self.target.dead and self.target is null, else face target. Okay. So this updates our facing to the target, updates the target when it's dead. And we move forward, self.speed. Okay. And then we need to check when we've hit the thing. If self.targets should we just do a contains check? I mean, the proper way to do it would be a line bounds intersection test, but that's kind of a pain in the neck and it's slow. I'm just going to do a contains check. So if self.target and self.target.contains self, then self.hit target. And return. Don't need to do anything else after we hit the target. Projectile.hit target equals function. So we want to do some damage. I don't remember how we do that. How do we do that? Take damage. No, seems easy enough. Give it an amount. And the amount should be stored on the projectile, so we can vary that later. So projectile.frames left. Projectile.damage equals. I want these things to hit pretty hard. 30, let's say. So if, well, this should never be called when we don't have an enemy. So for now, I'm just going to assume we have a target. Take damage, self.damage, and then the projectile needs to die. So self.frames left equals 0. Yeah, no, we'll just do this. Okay. Let's try that. Reset run main. Ooh, look at that thing. Yeah, kite these guys over here and the tower takes them out. It's still firing, even though there's no enemy there. I'm not sure why it's doing that. What are you firing at? Honestly. T is our tower. Turret. Target. Our tower turret target is an enemy. And it's dead. Oh, right. We didn't have the tower pay attention to that. Edit tower. Said it was going to do it, but I didn't do it. So self.target and self.target.dead. Then self.target equals null. So sitting there firing at the carcass of a dead enemy the whole time. Reset run main. Oh yeah. Come on, you guys. Come on over here. Follow me. Nice. Bloop, bloop. Oh, he takes him out. I think our enemies only have like 10 hit points, don't they? Yeah, so it's one shot at them. Hit points 10. Yes. All right. Let's edit our projectiles. Make it 4 damage, so then it would take 3 shots, unless the player can help out. That sounds more reasonable. Alright. Reset run main. Come here. Yeah. Alright, you guys, come here. Come here. Nice. And you. Come on then. Come within range of my deadly tower. Nice. Alright. So we didn't quite get the towers on the castle. That'll be next. And then the castle will be very well defended itself. We maybe won't have those towers hit quite so hard. But I'm pleased with how this works. In fact, I'm going to move it over before I call it a day. Put it over like here, closer to the castle. And that's a main. Let's see, instead of 300, let's go 600. And we'll move it down a little. Yeah. So, yeah, it just barely can't reach some of the enemies, but it can reach a lot of them. Come on, give me more enemies. Here they come. Nice. Very cool. All right. So let's recap. What did we do today? We started off by fixing a bug that I had left in the code. That was a little embarrassing. But it was just a matter of making sure that all the right imports were available in all the modules that need them. Then we created a projectile class and got that working, and then a tower class. And we've now got a tower that can fire at the closest enemy and apply damage and eventually take them out. So, very cool. We did not get to towers on the castle, so that'll be first on our list for next time. And then after that, we'll start making a map using a tile display to limit where the player and the enemies can go. And after that, we'll have to put in some pathfinding so that they can still work their way towards the castle, even if they have to take a windy route around the obstacles to get there. And then sometime soon, we'll have to put in an economy and some way for the player between waves to place new towers. And it'll start to feel like a proper strategy action game. So that's it for today. Remember, if you have any questions, leave them in the comments and I will reply as soon as I can. Or come join us on Discord, where we have a real active community, always friendly and eager to help out and chat about coding in MiniScript. Until next time, happy coding.